Hi, I am Sheikh Mahbub Basha. Welcome to my channel. Happy learning.
Hi students, yesterday in class 1 we have discussed about the rest position and motion of objects, and later we discussed about the concept of motion and rest are relative. So any object is said to be at rest with respect to some other object. Any object is said to be moving with respect to some other object. Always to say an object is moving or at rest, you need a reference. That is what we have discussed. If a body is changing its position from point to point, time to time, then it is said to be in motion. If the body is not changing its position time to time, then it is said to be at rest. These 2 points were also discussed. Okay, today we will move to scalar, vector, distance, displacement. We will learn what is a scalar, then what is a vector, then what is a distance, and what is displacement. We will discuss few examples, some 7-8 examples to understand the concept of distance and displacement. Let us understand what is scalar and what is a vector. Let us differentiate and also understand these two, scalar and vector. Point number 1. A scalar is the physical quantity having only magnitude but no specific direction is called a scalar. The physical quantity having only magnitude but no specific direction is called a scalar. Whereas the physical quantity having both magnitude and direction is called a vector. The physical quantity having both magnitude and direction is called a vector. Let us specify the important point of this definition as second point. It means the scalar. It has only magnitude. It has both magnitude and direction. A vector has both magnitude and direction. Now, let me write an example as point 3. You can take a distance is an example for scalar and displacement is an example for vector. So scalar is having only magnitude, vector has both magnitude and direction. Example for scalar is distance, example for vector is displacement. Let us draw a table for this. So generally you will be asked
To write the differences between scalar and vector, you can write in this table form. Or if it is asked in general, you can write without table. Other examples of scalar. Let us write some other examples for scalar. Time, mass, length, temperature, speed, work, power, etc. are examples for scalar. You can write even area, volume, density, so many examples are there. Now, let us write other examples of vector. Other examples for vector. Velocity, acceleration, force, momentum, etc. Representation of a vector. Geometrically, on paper, on board, how we represent a vector. A vector is represented by a line segment, let it be AB. This length AB, length of this segment AB represents magnitude of the vector. Length of the segment AB represents the magnitude of the vector. And the arrow mark represents the direction of the vector. It has 2 points A and B. This A is called a starting point. It is also called as origin. It is also called as tail. Three names: origin, starting point, tail. On the other hand, the point B is called terminus, end point, and it is also called as head. Tail and head are used as a pair. Starting point and end point are used as a pair, and origin and terminus are used as a pair. Now, a vector is represented on a paper. Length of the segment AB represents the magnitude of the vector, and this arrowhead represents the direction of the vector. Let us discuss about distance and displacement. Already we have given these two as examples for distance is an example for scalar, displacement is an example for vector. Now let us discuss distance and displacement. There is a ball, it is thrown into air, it moves along a curved path. So let us note down its intermediate positions. So this ball has passed through this curved path. Let the starting point is A, end point is B, and let us name the intermediate points as C and D. Then distance is equal to ACDB. That means that curved path length. So ACDB path length is the distance. The ball has moved along ACDB. Length ACDB is the distance. So the actual path followed is the ACDB. Its length is the distance. Now displacement. Displacement is the shortest distance between the starting point and the ending point. That is A and B in this example. Starting point A and end point B, shortest distance, straight distance from A to B is the displacement. So distance is represented by the symbol D, displacement is represented by the symbol S. Here displacement is equal to AB and its direction is from A towards B. Its direction is from A towards B. Both the distance and displacement are lengths only. Distance is along the actual path followed. Displacement is shortest from the starting point to end point. Here D is greater than S. Distance is greater than displacement. Direction of displacement S is from A towards B. The direction of displacement S is from A towards B. The SI unit for distance is meter and the CGS unit for distance is centimeter. The SI unit for displacement is the CGS unit for displacement is centimeter. So SI unit is meter for both distance and displacement and CGS unit is centimeter for both distance and displacement. And 1 meter is equal to 100 centimeters. You know this relation. 1 meter equal to 100 centimeters. Now let us understand with few examples. Example 1. Suppose this is a circle. Draw two perpendicular axes. O be the center of the circle. Note down the points A, B, C, D. A particle has moved from A up to B along this circumference, along the arc AB. So A is the starting point, B is the end point. Here distance D is equal to, if R is the radius of the circle, this AB is 1/4 of the circumference. Therefore, you can write 2 pi r by 4 and it is equal to pi r by 2. Whereas displacement S is equal to from A to B shortest distance. From A to B shortest distance. Draw a straight line. So at O there is a right angle. OA is one radius, OB is another radius. So a right angle triangle is formed. OA, OB, OA is R, OB is R, then hypotenuse will be square root of side square plus side square, that is R square plus R square, that is equal to root of 2R square, that is equal to root 2 into R. So displacement S is root 2R. Example 2. Suppose a particle has moved along the circumference of the circle as shown here from A up to the point B. O is the center, R is the radius of the circle. Let these two positions are C and D. Distance D is equal to 2 pi R by 2. Total circumference is 2 pi R. So half means by 2. So that is equal to pi R. Displacement S is equal to from A to B shortest distance. From A to B shortest distance. So AO plus OB, that is equal to R plus R. A to O R, O to B another R. So that is equal to 2R. Let us take example 3. A body has traveled from A to B. From A to B, let the distance between A to B is 5 meter, and then it took a 90 degrees turn towards left and traveled up to a point C. First A to B, then B to C. AB and BC are perpendicular to each other. Let BC is equal to 4 meter. Then distance will be D equal to 5 plus 4 equal to 9 meter. Whereas displacement is the shortest distance from starting point A up to the final point C. So we have to take AC. So AC will be the hypotenuse of this right angle triangle, that is equal to root of 5 square plus 4 square, that is equal to root of 25 plus 16, that will be root 41 meters. Now, example 4. A particle has started from A on the circumference of the circle of radius r. It started from A and completed one circle and finally reached the same point A. From A again to A. It has traveled from A to A. Distance D is equal to 2 pi r, that is the circumference of the circle. Whereas displacement S is equal to A bar is equal to 0. Distance from point A to point A is 0. So here displacement is 0. So this is an example where displacement can be 0. So we can state that displacement S can be equal to 0 in some cases. Right. Now example 5. A body started from point A, reached a point B, and again it started from B back to point A. So started from A, reached B, again returned back to point A. So distance D means the actual path followed AB plus AB, that is equal to AB. Whereas displacement S is equal to A, starting point A, final point A, distance from A to A is equal to 0. So here displacement is equal to 0. Now example 6. A person started from point A and reached point B, let it be 5 meter, and returned back to a point C, which is behind A. So from A to B, then B to A, and continued from A up to C. In the return journey, continued up to point C, crossed A and then up to C. Distance D is equal to AB plus BA plus AC. That is equal to 5 plus 5 plus 3, that is equal to 13 meters. Distance mean actual path. So AB 5, BA 5, AC 3, total 13. Whereas displacement S is equal to AC bar, that is equal to minus 3 meters. Minus 3 meters. This minus is to represent that the final point C is behind A. Initially it is started from A towards B. Finally it is at C, which indicates the direction back from A to C. So this minus sign indicates behind A, behind A. So here the displacement is minus 3 meters. Therefore we can say that S can be negative. S can be negative. Then example 7. A body has moved from A to B. From A to B along a straight line, and here the distance AB is 8 meter. So distance D is equal to AB, that is equal to 8 meter. And displacement S is equal to again 8 meter. Here shortest distance is same as the actual distance. So D is equal to S. Distance and displacement are equal. So in a straight line motion, distance and displacement are equal. Now example 8. Here is Hyderabad. Let this is the road path to Vijayawada. Then let it be the road path to Vishakhapatnam. So from Hyderabad to Vijayawada to Vishakhapatnam, road map we are drawing. The distance from Hyderabad to Vijayawada, let us take for example 400 kilometers. And from Vijayawada to Vishakhapatnam, let us take as 350 kilometer. So distance from Hyderabad to Vishakhapatnam is 400 plus 350, that is equal to 750 kilometer. Hyderabad is the starting point, Vijayawada is the intermediate stage, Vishakhapatnam is the final destination. Displacement S is equal to from Hyderabad to Vishakhapatnam shortest distance. So draw a line like this. So this is called a telescopic distance. So this is a telescopic or shortest distance from starting point Hyderabad to end point Vishakhapatnam. That is equal to 600 kilometer. So here D is greater than S. So D is greater than S. So distance always greater than 0. That means positive value. So in all the examples we have discussed, we never got D value 0 or less than 0. D distance is always greater than 0. Displacement S may be greater than 0, that is positive value. Maybe displacement may be equal to 0 in some of the examples we got, and displacement may be less than 0 in some of the cases we got negative value. So displacement may be positive, may be equal to 0, may be negative value, whereas distance is always positive, always greater than 0. So distance is always greater than or equal to displacement. Distance is always greater than or equal to displacement.
Okay, students, I think you understood what is a scalar, what is a vector, then what is a distance, what is a displacement, then the distance is always positive and the displacement may be positive, negative, or sometimes equal to 0, and the relation between distance and displacement is distance is always greater than or equal to displacement. Okay, so tomorrow we'll meet with the next topic. Till then,